Hello and welcome. In this video we will derive some trigonometric identities. In this triangle ABC, angle C is 90 degrees. And alpha is the angle at A. From this right angle triangle, the trigonometric ratio sine alpha is the opposite side BC divided by the hypotenuse AB. And let these sides be A, B, and C for hypotenuse. In this case, sine alpha is the opposite side of angle alpha, which is A, divided by the hypotenuse C. And cos alpha is the adjacent side of alpha, which is B, divided by the hypotenuse C. Now let these be 1 and 2, squaring and adding 1 and 2. We get sine squared alpha plus cos squared alpha equals to a squared over c squared plus b squared over c squared, which is c squared in the denominator, a squared plus b squared. Now we know from the right angled triangle a squared plus b squared is equal to c squared. Therefore, replacing a squared plus b squared with c squared gives you c squared over c squared, which is equal to 1. Therefore, sine squared alpha plus cos squared alpha is equal to 1. This is one identity we derived. Now we know from this right angle triangle sine alpha is the opposite side A divided by the hypotenuse C, and cos alpha is the adjacent side B divided by the hypotenuse C, and also tan alpha is the opposite side of alpha A divided by the adjacent side of alpha, which is B. Now we'll derive tan alpha in terms of sine alpha and cos alpha. Let us express tan alpha in terms of sine and cos. Let us call this equation 1 and this equation 2. Now dividing 1 with 2 gives us sine alpha divided by cos alpha, which is A divided by C and divided by b divided by c, which is equal to a divided by c multiplied c divided by b. That gives you a divided by b, which is same as tan alpha, which is a divided by b. Now we expressed sine and cos in terms of tan. We expressed tan alpha in terms of sine and cos. So tan alpha is equal to sine alpha divided by cos alpha. So that is one identity. Sine alpha is a divided by c, cos alpha b divided by c. Let these be equations 1 and 2. Now we know from sine squared alpha plus cos squared alpha equals to 1. Let us call this equation 3. Now dividing equation 3 on both sides with sine squared alpha, gives you sine squared alpha divided by sine squared alpha plus cos squared alpha divided by sine squared alpha is equal to 1 over sine squared alpha. Now that becomes 1 plus cos alpha over sine alpha squared equals to 1 over sine alpha squared, because 1 over sine squared alpha can be written as 1 over sine alpha squared, which is same as 1 over sine squared alpha. Now this becomes 1 plus cos alpha over sine alpha is 1 over tan alpha, because we know from identity tan alpha can be expressed in terms of sine alpha and cos alpha. And we know from the reciprocal identities 1 over sine alpha is cosecant alpha. One plus 1 over tan alpha is cotangent alpha, also known as cot alpha, squared is squared here, which is equal to cosecant squared alpha. Now we have another identity in terms of cot and cosecant.